Hello and welcome to the Unit 4 Section 1 video on linear functions. So here we're going to talk a little bit about an introduction to linear functions, and we're going to talk about what makes a function linear and what makes it nonlinear. In other words, what is a linear function and what is not a linear function. So we're going to start off by talking about graphs. Okay, graphs that are straight lines are linear functions. Now, we can also tell if a function is linear or not by looking at a few other things. So if we take a look at two sets of points, they have to have a constant rate of change between any 2 points. So in other words, if we have a list of points, then the difference between the x values have to be the same and the difference between the y values have to be the same, or the ratio between our change in y to our change in x has to be the same. Now, the highest degree of any term, if you're looking at an equation, has to be 0 or 1. So remember, a degree is your exponent. Your exponent cannot be any bigger than 1 for it to be a linear function. So if you have a x to the second or x squared or an x to the third or x cubed, you cannot call that a linear function. That would be a non-linear function. So let's talk a little bit about what a nonlinear function is. Well, nonlinear functions have graphs that are curved lines. They do not have a constant rate of change between any 2 points. And the exponent is something other than 0 or 1. Now, in both talking about linear functions and nonlinear functions, we've talked about an exponent being to the 0. Let me just remind you what that means. Something that is to the 0 power, so like x to the 0, that's simply 1. Anything to the 0 power is 1. So if you do not have an exponent on a variable, if it's just x, that exponent is understood to be 1. We just don't write the 1. So if you see a number exponent, typically, it's not going to be a function. And there's also going to be a few other things to look at in equations to determine whether it's a linear function or not. And we'll talk about that here as we go through a few examples. So let's start off with a couple of graphs. We are going to determine whether each of the following represent a linear or nonlinear relation. So first of all, this is a straight line. So since it is a straight line, it is linear. This one is a curved line. So since the line is not straight, it's curved. This one is nonlinear. All right, let's take a look at this equation. We have something with x to the 1 power. There's no higher exponents than 1, so this one is linear. For the next one, we have a squared power. So since we have a power bigger than 1 on our variable, then it is nonlinear. Now let's look at a couple of tables. Our change in y has to be the same as our change in x, or at least the ratio between the two. So let's take a look at our x's first. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. Okay, so that changes by the same number. What about these on the bottom? Well, 4 minus 1 is 3. 9 minus 4 is 5. And then 16 minus 9, well, that's going to be 7. So the y's change at a different rate as compared to the x's. So therefore, this is non-linear. And in case you're wondering, this is actually a squared function. All right, let's take a look at the next table. In the next table, we have 6 minus 3, which is 3. 9 minus 6, which is 3. And 12 minus 9, which is 3. So since all of our x's are the same, we would expect our y's to be the same. 10 minus 12 is negative 2. 8 minus 10 is negative 2. 6 minus 8 is negative 2. So here, our x's change all at 3, our y's all change at negative 2, so this one is linear. For this next table, 3 minus 0 is 3. 6 minus 3 is 3. 9 minus 6 is 3. How about 9 minus negative 3? Well, that's going to be 9 plus 3, which gives us 12. 21 minus 9, that also gives us 12. And 33 minus 21 is also 12. So this one is linear. And the key here is that our y over our x is 12 over 3. Our change in y, which is 12, and our change in x, which is 3, is 12 over 3, which is 4. We want that ratio to be the same all the way through. Every change between 2 points needs to reduce down to 4. All right, let's check out the next graph. So here we have a straight line. So since we have a straight line, it is linear. I think in graphs it's the easiest to pick out. Is it a straight line? If so, it's linear. If not, it's nonlinear. This one's got a square on it, so this one is nonlinear. This graph is curved, so this is nonlinear. This equation, our highest power is 1, so therefore this one is linear. All right, back to a table again. 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. 0 minus 3 is negative 3. Negative 3 minus 0 is negative 3. Negative 6 minus negative 3, which is negative 6 plus 3, is also negative 3. So this one is linear. By the way, if you have a table of values, you saw how we determine whether or not it's linear. If you have a set of ordered pairs, it behaves exactly the same way. A set of ordered pairs are just a set of x's to y's, just like a table. So if you're presented with a set of ordered pairs, you're going to determine it just like you do with a table. All right, this one, our highest power of x is 1. X is in the numerator, okay? This is just like saying 1/2 x, okay? This is just the same as 1/2 x. So if this is 1/2 x, x is in the numerator, then 1/2 is just our coefficient. It's just the number in front of our x. So this one is linear. All right, back to a table. 5 minus 6 is negative 1. 4 minus 5 is negative 1. 3 minus 4 is negative 1. 15 minus 21 is negative 6. 10 minus 15 is negative 5. 10 minus 6 is negative 4. So our ratio is different. Here it's 1/6, here it's 1/5, here it's 1/4. So this is nonlinear. This one has a curve to it, so this is nonlinear. Let's do a few graphs here. So this one is curved, so it's nonlinear. This one is straight, so it is, well, I was going to write it as a straight line, but it is linear because it is a straight line. This one's curved, so it's nonlinear. This one's a straight line, so it is linear. This one is curved, so it's nonlinear. And the last one is curved, so it is also nonlinear. Let's check out some of these equations. So this one, the highest power is 1. So we have linear. And this one, the highest power is 2, so this one's nonlinear. Now here we have the highest power of x is 1, but x is in the denominator. Anytime you have x in the denominator, it is going to be non-linear. The only case where it would be linear if x is in the denominator is if you have an x squared maybe in the numerator and the x's cancel, and therefore you just end up with an x. So remember, if you have an x in the denominator, just have a number in the top, it's going to be nonlinear. This one has a power of 3, so this one's nonlinear. This one has just a number, but the highest power here is 1, and if we had an x on the end, it would be x to the 0, which is 1. So y equals -6 is linear. In fact, you know it's a straight line because y equals -6 is a horizontal line. And then here we have x in the numerator. This is just like saying -5/2 x. So this one is linear. Back to some tables. So all of these are changing at a rate of 1. So between 1 and 2 is 1, 2 and 3 is 1, 3 and 4 is 1. Here we got 5 to 7, which is 2, 7 to 9 is 2, 9 to 11 is 2, so all of that's the same. So this one is linear. Here we have 0, -2 to 0, which is 2, 2 to 0, which is 0 to 2, which is 2, and 2 to 4, which is 2. 0 to 1 is 1, 1 to 3 is 2, 3 to 9 is 6, so this one is non-linear. So you can kind of start looking at some of these tables and just determine it. So here we have a change of 1, change of 1, change of 1. Our x's are all 1. Here we go down by 4, down by 4, down by 4. All of those are the same, so this one is linear. In number 16, we have 2 to 3, which is 1. The change here is 1. The change here is 1. So all of our x's are 1. Here we have 3 to 5, which is 2. Then 5 to 8, which is 3. 8 to 12, which is 4. So all these change at different numbers. So this one is nonlinear. All right, this one, -2 to 1 is a change of 3. 1 to 4 changes by 3. 4 to 7 changes by 3. So all these are 3. -4 to 1 is 5. 1 to 6 is 5. 6 to 11 is 5. So this one is linear. And then finally, 3 to 6 is 3. 6 to 9 is 3. 9 to 12 is 3. So all those are 3. This one goes down by 4. And then this one goes down by 3. This one goes down by 2. So that's not the same. So non-linear. So this section was all about determining what's linear, what's not linear. As we go on to the next section, we're going to be talking about average rate of change and slope. How do you identify slope? How do you find slope? What is slope? We'll be chatting about that here in the next section.